Hello explorers and welcome to another video. Today I'm going to talk a little bit about test-driven development, TDD. So in this video I want to go through how you can use TDD to structure your workflow. And this video is going to be a little bit different because I'm not going to go into much in detail how I actually wrote the code or how the code is actually, what the different things in the code are doing. I'm more going to go through how I ended up creating this little tool. And I'm not done yet. I will have to work a bit more on it. But as I know what the end result should be, it's very nice to be using TDD to structure your problem, break it down, and then handle each part separately. So first off, I had a document. It's a specific format for Braille, and it's called PEF. And in this document, you have some metadata, not important for my problem. You have volumes, and these volumes can have sections, and then you have pages and rows in these sections. The first section here could be a title page, or you can have a few sections of title pages, and then you have either can have a section, but this is optional, of an table of contents, and then you have the section with the actual content. And the table of contents have Roman numerals as the actual page numbering, and the normal section pages has two sets of page numbers. You have the normal page numbers, which goes from A and up, so you use A instead of 1, and you use J instead of 0, so you have A, B, C, D, E, all the way up to J, and they are actually converted to the normal decimal numbers. And on the left hand side here you see that I have G, and G is actually the page number of the original book. So this is the page number of this PEF book, and this is the original number. And down here you see that this had A here, and then you have B down here, so this is the second page, and B is number 2. But this is the left side page. So you have a right side page with the numbering on the right hand side, and then you have a left page with the numbering on the left hand side. So you have to switch sides as well. And then you can have ranges of the original numbers, and these are added like this. And this is pretty much what you need to know about the structure of the document. I'm gonna try to figure out how to read. And the problem I want to solve is reading a document. Can I see if there is any empty pages? Which means that you have a page number, but you don't have any rows except for this initial row. And I also wanted to see that the actual page numbering of the PEF files, these don't have any breaks in them. So you actually have a sequence of pages, and there are no missing pages. So this is what the tool I'm gonna build is gonna do. So for this, I identified that I needed some data structure, and I wanted to keep the original start page and the original end page. So these are the pages in the original book. I want the PEF page, and I want to know if it's empty. So this is the data class that I created, and this data class has a lot of getters and setters, but that's not important for this code. And then I sat down and wrote some functions. I knew that I needed a main function that had to do something, so I gave that a little bit of a documentation here, what I wanted to achieve with this. And then I want to process a document, and I didn't know exactly how much this function should do, so I just added an empty comment here and thought maybe I add some more comments to this later. I know that I need to get the page number. I need to have a function that actually reads both of these kinds of numbers and that can handle the page numbers for me. So I created this one and I documented how I wanted it to work. And then I also wanted to have these page identifiers so I can actually get the full data set for this page. And I thought that if I give it a page element, an element in XML is one tag. So in this case, I give it a page element, and this should in turn return the numbers and if it's empty. So that's what I documented up here. So this was what I did at first. They didn't have an implementation at all. And then I created a test class. And you see here in this test class, I added a lot of tests. First off, I wanted some incorrect page numbers. So here you have something that doesn't have this numeral sign in the beginning, and then you have something that has a Q in it, and that's not allowed. So these will fail. So I wanted to have a few of those that gave the result -1 back. And then I had a few here that gave me the numbers for different pages. You see here AJJJ, that's 1000, so it can handle thousands. So I thought I wanted to handle pretty large numbers, and I wanted to have something that can handle arbitrary long numbers, but I thought that this was a reasonable amount of test assertions to see that I actually can handle a lot of numbers. And then I wanted a test to handle incorrect Room-alone numbers. And the strange part here is that you actually must have 2 underscores if you have 2 or more letters in your Room-alone numbers, and you can't have 1 in front of 2 of them. So you should have 1 when you only have 1 Room-alone character, and you should have 2 if you have more. So I just put in some test cases for that to see incorrect numbers. And then down here you have, similar to up there, a few Room-alone numbers that I check. And the last one here is the most funniest or interesting, that I can actually handle 2019. So this is a little bit more challenging than the rest. So this is what I had in test cases. And after I did this, I actually went in and implemented this page number function here. And we're not gonna look at that more. I did it, and all the test cases actually ended up working, and I didn't have any test fails. So now we have jumped forward in the process a bit. So now I've implemented even more things. And as you see here, I actually didn't implement this process page. I thought it was good to actually break it down even further. So the next thing I implemented was this get page identifier. So this is the object that I had before that actually have the information about the page, if it's the start and end date pages of the original book and the PEF page and so on. So I wanted to have something that can give me that and to ease the work. So this function takes a row of a page identifiers and extracts the page numbers. That's the documentation here. So it takes a row in string form. I need to tell it if it's a left-hand side page, so I know where the numbers are actually located. And I also want to tell it if it's an index page, so if it's using Room-alone numbers and only have one set of numbers. So this was what I documented here. And then I went back here and created some tests again. And I tested we can extract index pages here. So this is all these Room-alone numbers that I can. So I get the first page. So this is one page, or the first index page. And then I see that I can get the second index page. And I also send in these values here. And because it's actually an index page, the left or right hand side doesn't really matter, because I can trim the a line totally, and I still get the number even if it's left or right aligned. So I look at that, and I also see that I can handle the 9th page. Maybe a little bit overzealous, but I thought at least 3 test assertions could be good. And then I created a test so I can test normal pages. So here you see that I have the A here. So this is the first page, and then I have the original book is 23, I believe. So I handle here that I can have 1 and then 23, and it's not a range, so that should be -1. So this is the first assertion set. And then I want to handle that it's a left-hand side page. So the numbers are actually on the left side, the PEF page. So I see here page 2, 23, 24. And lastly, I took a really large number. So this is 410th, and then 208 to 210. So this is my last test here. I didn't have any adverse or incorrect test cases here. I just had the positive ones. So that might be something I can improve on. I can see if I can figure out some test that breaks as well, so that this could actually be improved. And when I had done that, I went back, of course, to the PEF check again, and I implemented this page number function again. So this will handle all those cases. And the important part with all these implementation is, for me at least, that I create all the incorrect functions first. So I see that all the things that should fail actually fails. So I see that I can handle all these strange cases. So if we go to the get page number here, I will handle all the allowed syntax. I will have some regex here that looks and sees that I have the correct syntax for all page numbers. Hello again, we are back, and now we have jumped even further in front of the history. So now I have implemented the process page function. So this will take a page, and if it's a left-hand side or a right-hand side page, we still have this documentation here. And after I've seen this documentation, I sat down and created some tests again. So first I wanted to check the incorrect page object. So I was thinking, okay, what can be incorrect about the page? We can have an incorrect page tag. So I created one of those, and that will throw an invalid format exception. So that was what I wanted to check here. So I will see that it actually throws something. And then I created a correct page tag, but it didn't have any rows. So it was empty. And that should throw something as well. And then I created something that has a row but no text in it. So we don't have any page information or page number information. And that is also an invalid formatting. So that will throw an exception as well. And lastly, I set some text to the row. And this is not a correct data for an index. So that will throw an invalid format exception as well. And then I created some tests for correct page objects. And in this case, I just created a page with a row, and then I created some data here. And I wanted to assert that this data here, with just one row with text in it, actually went back and said that this was page number 1, 33 again, and then 1. So all these are actually assertions from an earlier tests. But I wanted to see that those were handled correctly through this process page. And then I also wanted to see that this is an actually empty page. So it doesn't really have any text. It only has one row. And then I will create the second row here and add that to the page, and then run the validator again. And here I want to see that this is empty is false. So these are the test cases for process page. And then I went back and I created implementations for these. And here you see that I started off by actually checking all these errors that could occur. It should have the correct tag, the row should be present, the data should be not empty, and then I did and actually went and fetched the page information, and if the PEF page is not correct, then I have an invalid page number, so I couldn't actually fetch that. And then I will set the page identifier to empty if the number of rows are less than 2, and I will return that information back. So this function was pretty simple, so that's why I'm going through that. But you see the structure. I started off by actually handle all the edge cases that I had come up with, and then I created the golden path. And we're back, and I have now created something I call process section. I was so eager, so I forgot to actually write down my thoughts here and create something that could be documented in this function. So this I will need to improve on later on. But this process section will take a section element. So if we look at the structure again, a section is above page. So a section has pages and then rows. So we are moving up in the structure. So this process section will get the section, and if it's an index section. So I need to know if it's an index section, and then I will handle that section. Then I went back, wrote some text again, and I wrote some tests to handle incorrect sections. So again, if it's not the correct tag, I want to check for that. I want to check if the section is empty, and I also want to check if the section has a page but that page is empty. And I have some naming issues here. We should actually rename that to page. And then I will test some normal sections as well. So I create a section here with the first page and the second page, and we see here that the first page has a second row. So I have actually created a function to create rows because that is tedious to have, and it creates a lot of extra code that is not necessary. And we can look into that function. It's quite small. It just creates an element, sets the text, and it gives that element back. Creating document is also tedious, so I created a little bit of a helper function for that, just to move some of the code away. And then when I created these, I wanted to have a lot of assertions here. I wanted to check all the page numbers for the first. I wanted to see that it is not empty. And then I wanted to check all the page number for the second one, and I wanted to see that that one is empty. We don't have any second row here. So this is normal pages. You see here that you don't have any Roman numbers here. Roman numbers, it's normal numbers. And then I created this index sections down here. So these have Roman numbers, and I add this true flag to this process section, and I just put this in, and I wanted to see that I get page number 1 and page number 2 out, and also can see that I can handle empty and not empty pages. The implementation of this section function is also quite easy. I go through and see the edge cases here when the section tag is incorrect and the pages are not present. And then I will go through the list here and add a list of page identifiers where I process the page and give it the index section. And I also have this boolean that will switch between left and right side page with this little switch down here. So I will handle the switching of pages through the book. And for the last commit that we are going to look for today, we are actually tying it all together and creating the full program, not with the validating part. I will handle that later on, but I thought that going through and actually reading the full document with this process could be a good way to show off the power of TDD. And then here we have the main program. So I have some arguments up here, not important. And then I will read the document from the arguments. You send in what document you actually want to read. And then I create this PEF validator here. And I will process the document of this validator. So I will run this process document. Now that I want to run it, I needed actually to document it. So I wrote small documentation here, finding the sections could handle in different ways. And it's an XML document, and it will throw exception if it's not well formatted. This process document was not that hard either. I create an XPath here. I search for volumes, and I go through that volume list here. And for each volume, I will search for sections and take all the sections down here. And as we know, there could be one or more title pages. So I will actually start from a set amount of title page. And I had this private variable here for a long time. So this title page is set to 1. So I will always have one title page. And then I will go through this for loop, get each section, and I will process that section. But when I actually set the process section here, I remember that we have this Boolean here that tells us, is this actually an index section? So I thought that the easiest way to handle this was to create a function that actually tells me if it's an index section and if we have to handle Roman numerals. And this function is down here. So I created this one with Boolean and I documented it. This function checks if the current section is containing a page index and should therefore use Roman page numbering. So when I had wrote this, I went over to the test and created some tests again. And when you are checking a section, you have the same functions here. You check if it's not a section, so if it's an invalid section. And then we will throw a format exception. We will check if it's empty. We'll throw a format exception there. And we will check the page. If the page is empty, we will throw a format exception there as well. So these were the minimal bad paths that I could have tested. And then we want to handle index sections. So I created this very small section with one page. This page had an index start, and I appended that and checked that it's actually true. And then I created this normal pages here, and that should return false for this function. And you see here that this is a very standard first page in a Roman in a normal section. And then I wanted to implement this. And again, I went through the bad phases. So I checked if the section is correct. Otherwise, throw, length, throw, get the page, length, throw again. So now I have done all the bad paths and handle those. Then I can get the first row because I know that I have this row. And the implementation of this is statement is quite easy. I get the text content, I trim it, and I see that it's equal or equals ignore case to this Roman number of the first page, because each section in the each table of contents actually starts with the first page. So it always starts over in the numbering. So that's very easy to check. So this is the index section, and my process document is done, and the program can actually read the document. So later on I will add the actual validating code. I have started with a little bit of a documentation for those functions. If I check out master here, this is what I want to go forth and implement perhaps tomorrow or something. So I have two functions here that doesn't do anything, and I haven't written any tests for them yet. So this function will validate the page sequence to check for page ranges missing. It will report when it finds a sequence of missing numbers and throw an exception. So that's one function I want to implement. And then I have this has empty pages down here, and this function runs a page list and looks for empty pages, reports the PEF numbering missing, and returns the result. So this is what I have written so far for this little tooling, and it's something that I write for work, but it's open source. So I thought it was fine to go through it and show you a little bit about how I work. When I have a problem that is defined, I know how to solve the problem. I could write something very simple to solve this problem, but it is a little bit complex and there are a lot of moving parts. And this case, I think, is a very good case for using TDD. So when you have something that you pretty much know how the end result should be, and you know a little bit of how to get to that state, but you want to validate each step of the way and break down things to smaller parts, then test-driven development is really good for that purpose. A lot of things I do in my day-to-day work involves exploring new possibilities or exploring different ways of doing things. And those cases I don't think test-driven development are as good for, because then you don't really know where you want to end up and you don't really know how to implement the code or what to test for, because you haven't worked with it before. You don't know the domain even in many cases. So if you know what the end result should be, and if it's something that you can define, you can think about it, it's easy for you to think about what's the bad cases for this and what's the good cases. Then you can write tests for all of these and go forward with test-driven development. The thing about writing tests is that you actually are creating something that will validate your code. So what will take time is writing tests, and the code will be quite fast to create, because you run your tests. If they fail, you need to figure out why did just this test fail, and then you run them again and you figure out why, run them again. And each of these loops running through takes about a second. So you don't really lose any time in running large data sets or anything like that. You run your small unit tests, you get the result directly, you do small changes, run the tests again, and when you actually find a way to write code that passes all your tests, if you have written the right amount of tests or enough tests that actually covers all of your domain, then you can reasonably be sure that the code you write is also solid. This is what I wanted to cover today. I hope that you found this video interesting. I hope that you learned something today. If you have any question about test-driven development, or if you want to see more about this, please leave a comment in the section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.